Welcome back to Math with Miss Swartz. Today we're going to be looking at the distance formula. There are two ways to find distance, and we've already talked about one of them. The Pythagorean theorem is one way we can find distance when we're working with triangles, but maybe it's a little difficult to create a triangle with the information that we have, or it would take a little bit of extra steps. So we want to find another way that we could find the distance if we are working with just two ordered pairs. So that is the distance formula. On the next slide, I'm going to show you the distance formula. Please write it down. It's one of those that it may look confusing at first, but once you understand kind of where each piece goes, it will make a lot more sense. So here's the distance formula. D for distance equals the square root, that's why we've been working with square roots, of, okay, and then in parentheses we have x2 minus x1 squared. Okay, now these pieces right here do not mean anything besides telling the difference between this x and this x. Okay, and then plus, in parentheses, y2 minus y1 squared. Okay, again, these are just telling us the difference between the two y's. So when we're working with the distance formula, we will have an x1 and a y1, and we will have an x2 and a y2. So the steps to working with the distance formula, make sure you write this down. This is important. You will probably be expected to memorize it. So we have the square root of x2 minus x1 squared plus y2 minus y1 squared. So how to use it? It says substitute your values into the formula, so you'll get two sets of ordered pairs, like I already said, x1 and y1, and x2 and y2. You're going to plug those in to the formula. You're going to use the order of operations to simplify under the radical, so you're going to do everything inside the radical symbol, since the radical symbol is that whole piece. And then you're going to use your calculator to find the square roots to the nearest tenth. Okay, so let's get started on some examples. Make sure you write how to use down, and then we will jump into our examples. First example, it says find the distance between the 2 points. We have, it should be in here, -1, 6, and 5, -3. Okay, so we're going to do the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so we take the square root. Now we're just going to plug in what we know. So you can write these above if you'd like. This is x1, y1, x2, y2. So we have our x2 is going to go here, 5, minus our x1 is going to go here, -1, and we're going to square that. Then our y2 is here, -3, minus, and our y1 is here, 6, and we're going to square that. So we've now put them into the formula. We just need to use our order of operations to solve. So my order of operations under the radical tells me to do my parentheses first. So I have keep, change, change. So I would have 6 squared plus, and then keep, change, change, -9 squared. So I just did what was in parentheses. Now my next step would be exponents. So I have 36 plus -9 times -9 is positive 81. And then we would just add the two numbers. So we'd have D is equal to the square root of 36 plus 81, which would give us 117. Okay, and then we can grab our calculator and square root that and round to the nearest tenth, so it would be about 10.8. Okay, so let's look at this next one. It kind of ran out of room over here. I'm gonna try to do it up here. So our problem is -3, 4, and -7, 5. Okay, so I'll write the formula because I'm going to write the formula every time to help me. So I have x2 minus x1 squared plus y2 minus y1 squared. Plug in my pieces if I need to write x1, y1, x2, y2 to help you. That's great. So I'm going to plug this in. I would have -7 minus -3 squared plus 5 minus 4 squared. I just put these where they belong based on these. So if this is y1, 4 goes there. If this is y2, 5 goes there. Now I'll work some math. So I'm going to do my parentheses first. Keep change. So I'd have -4 squared, because negative plus a positive, okay, we would subtract. And then I would have 1 squared. I put the parentheses around the negative so I make sure that I work with those. So -4 squared would be 16, and 1 squared would be 1. So we would get d equals the square root of 17. And then we could use our calculator. D would equal 4.1. All right, so make sure you write these down. We have a couple more examples, and then you're going to try one on your own. Okay, here are our next two examples. So we have 2, -1, and 8, 1. So I'm going to write out the formula. D equals the square root, okay, of y2 minus y1 squared plus x. Nope, I mixed that up. I want to make sure we get the formula right. We'll go our x's first. Okay, so back to our pen. x2 minus x1 squared plus y2 minus y1 squared. Okay, now if you were to draw these points out on a coordinate plane, you would probably still be able to use the Pythagorean theorem. So if we look at this, we have 2, -1, so we'd say about there, and then 8, 1. Okay, so if we had, this is what we're trying to find, we could always draw in these points and use just the coordinates to count the side lengths here, and we could use the Pythagorean theorem to find this distance. And we'll look a little bit at that depending on which class you're in, either today or tomorrow. But the distance formula is just one way, so we wouldn't have to draw that every time. That will work. Okay, so let's look at this one. We got x1, y1, x2, y2. So we got 8 minus 2 squared plus y2 is 1 minus -1 squared. Now we start with our math. Always parentheses first, so we get 6 squared plus, and then 1 plus 1. Let's keep change, 2 squared. So we would get the square root of 36, so we do our exponents next, plus 4. So D would equal the square root of 40. Grab your calculator, and that would give you 6.3 rounded to the nearest 10. Okay, same thing for this one. This is our x1, y1, x2, y2. So we would have, if I just started up here, write the formula out, always good, because that gives you a good start so you know where to go. Plug in your values. So this would be 8 minus -8 here, squared, plus, oops, this should be our x value, 2. 2 minus negative 8. So be careful when you're putting your values in that you don't make a mistake. And then we have 8 minus 6 squared. So this one we would have plus plus, so we would do 10 squared plus 2 squared. So we would get 100 plus 4. And I'm going to move this over so we have some room. D would equal 104, the square root of 104. So the square root of 104 is 10.2 rounded to the nearest tenth. All right, make sure you've written down all those examples. This is the one I want you to try on your own and show me when you are done. So I want to see the work. I want to see all the steps. I want to see the formula. So make sure you write it all out. All right, have a wonderful day.